Okay, so no one has joined till now. Let me wait a few minutes, then we can start. Okay, so today is our last class. Okay, and I yes, and 15th April, that means day after tomorrow, we will meet. That will be a special class. Okay, so okay, till now no one has joined, but you can start. Okay, you can follow from the recorded lectures. Okay, let me first share my screen. Okay, am I audible? I hope so. No one is here to verify that. Mm, cool. Okay, my screen is visible.
Yes.
Okay. So today I will cover some questions from the entire course syllabus. Okay, and the next class obviously that is scheduled on 15th. So in that class, I'll discuss that Gibbs Dome equation, Gibbs-Helmholtz equation, sorry, Gibbs-Helmholtz equation, and the uh, Joule-Thomson coefficient. I will discuss. Okay, so now let me start it. Why KCl, NaCl water system should be regarded as a three component system, whereas KCl, NaBr, H2 flow system should be regarded as four component system.
There
But
is two common Cl minus, so one more restriction added here.
one more restriction added here.
What?
Explain, what are you saying? What is our formula? We know that
P
C
minus
equals
C dash.
minus R, right?
Yes.
Now for KCl, NaCl and H2O, for this mixture, what is our C prime? That we have to understand first. What is C prime? And then we have to consider R. What is the R? Okay.
4.
So first, no. First, what is the C prime? That is important. Here, 4,
6.
6. Why?
K
KCl and
plus Cl
NaCl.
minus, Na plus Cl minus, and H plus OH minus.
So you are saying Cl minus and H plus OH minus. So it is 5.
Yes, 5.
But they are saying this is a three component system.
Two restrictions are there.
Which restrictions are there?
One is for the H2O, H plus and OH minus, and another is for these two.
No, KCl and NaCl will dissolve totally, right? KCl will because this is a salt. So it will be K plus Cl minus and NaCl will also be dissolved in Na plus Cl minus. So there is no restriction. When it is a equilibrium, then you can consider that as a restriction. But here how you can
If
attempt.
I know the number of K plus, then I can tell the number of Na plus.
Exactly. Yes. Exactly. So you are saying that, yes, you are correct. So the K plus and Cl minus, and here Na plus and Cl minus, these two are the restriction basically. Not this, you can think in restriction like that. But yes, these two will be subtracted. So that's why it is 5 minus 2
2.
and it will be 3. Or you can just explain like these KCl, NaCl, and H2O. There are three components. So when are you considering KCl, NaCl, H2O? That what I have said, you if you remember, we can consider both sides, either this side or this side. The answer will be the same. Components will be the same. Correct. So if you consider that side with the before dissolving, let's say that dissolve uh, that is not considered. We are not considering the salts are dissolving. Then also it will be KCl, NaCl, and H2O. So three components are there, and there is no restriction. So it will be 3 minus 0 and 3. Okay. So by this logic also you can do. But
I can
then
consider the left side also.
yes, both. But if you consider the right side, then you have to consider K plus Cl minus, Na plus Cl minus, H and H2O. That will be 5. And from 5, you have to subtract that K plus equal to Cl minus and Na plus equal to Cl minus. Two condition you have to subtract, and then you will get the 3, 5 minus 2, 3. Okay.
But it is same as the next one, but there is the 4 component system.
That NABR.
Yes.
No, but in case of NABR, what happens? Uh, NABR, in case of NABR, it
If I
actually
consider the
reacts.
left side.
If you consider the left side, KCl, NABR, H2O.
Yes.
No, that's I'm saying na. In case of NaCl, KCl, H2O, this is okay. But in case of NABR, NABR does not dissolve. NABR is not actually what I can say. NABR is not totally solvable. Okay, it's not that kind of solve. It will react. It will react with KCl. That just KCl plus NABR. This actually reacts, and after reacting, it's give us KBr plus NaCl. Okay, this kind of reaction is occurring there. So how you can't ignore that kind of reaction. Means when you have KCl and NaBr, if you want to consider the left hand side, you just understand. This is not very difficult to understand. When you are considering the KCl and NaCl, you can consider both sides because it will be fully dissolved. Okay.
Yes.
Simultaneously, you can't have K plus Cl minus and KCl. That you can't have. But here you because it's the equilibrium sign here, so you can have KCl, NaBr, KBr, NaCl all. Okay, so that is the
Okay.
important fact. So you can't if you here you can't consider this side only because if you consider this side, then automatically this side will appear because this is in equilibrium. But here, if you consider this side, then it's okay because it will totally dissolve. So either KCl is there or this K plus Cl minus is there. Both are not there. Both sides are not present there. Okay. So that is the important factor. So you have to consider both here in case of KCl and NPTEL, you have to consider both. So now just to calculate the C prime. So C prime will be and H2 is also there. So see you here also in this case also you can consider the
Six.
whole species. You don't need to consider the ionized part. Okay, here you can consider KCl as whole, NaBr as whole, KBr as whole, NaCl as whole. This you can consider. Okay, so then it will be 4
6.
plus 5. H2O is there, na? H2 is,
H2 I don't need to consider H plus OH minus.
uh, yes, so, yes, 6, right. And then what will be the restrictions?
One is for the H2O
And one is
and
for
one
the
is this equilibrium sign.
equilibrium. So it will be 4. So just if you consider both situation, then there will be only this equilibrium factor is there, right? Otherwise, everything is there. Okay, so it's clear. Now, it question number 2. Determine the number of degrees of freedom in each of the following systems. First one, A, liquid water and water vapor in equilibrium. And second one is liquid water and water vapor in equilibrium at 1 atm pressure. Okay, can you solve it?
For first one it's 1,
No, do it properly. C minus B plus 2.
C minus P plus 2. C is 1, P is 2.
B is 2, yes.
So for the first one it's 1 and for the second one it's 0 because there is one restriction.
C minus P plus,
C minus P plus 2.
it is 1. Okay, so one variable is needed here, degree of freedom. And for the
Yes,
second case, C is
one
1.
restriction is there.
Yes, C prime is 1, but C is 0.
1 minus 1 0.
Okay. So now it will be C 2, then it is 0 minus 2 plus 2. It's 0. Correct. So I think
Yes.
this. Okay, and today I will discuss on that third law of thermodynamics. Okay, that I forgot in last day. That I will discuss. This is third law of thermodynamics and residual entropy. I will just state. You know that part. In case of statistical thermodynamics part, I discussed that, but still here also I should just mention what is a residual entropy.
Okay.
So now the average bond energies of S8. This is a sulfur. Okay, I forget the name. Okay, S8 H2 and H2S are these are the average bond energies. Okay, that is 264, 436, and 338 kilojoule per mole respectively. Estimate estimate the enthalpy of the reaction, which is the reaction is S8 plus 8H2 Q7 8H2. Try it and what does what is the definition of bond energy?
Energy released when forming the bond.
Exactly, energy released when forming the bond. That means you can think like that. S8 to 8S for this reaction, the energy is required, right?
Yes.
So that means here del H is positive.
1048 kilojoule per mole.
1048 kilojoule per mole, correct. So how you do that?
Reactant bond energy minus product bond energy.
Yes, but how? Why that should be the enthalpy of the reaction? That is important. So what I want to mean, that is correct. You are doing you have done the correct, but that is the you have follow the definition. But just you have to understand why that is the definition. Because this is the bond energy, right? Bond energy will be needed here. So you can write it plus bond energy, then 8s, correct? Similarly for H2, you have to give the bond energy and then it will be 2H. And in case of H2S, then also you have to give its bond energy, average bond energy, obviously here. So then it will be our 2H plus
Plus
S.
S.
So let's say this bond energy is delta H1, this bond energy delta H2, and this bond energy is delta H3. Okay, now just keep this equation as it is. S8 plus delta H1, it gives us 8S. Multiply this equation with 8, then it will be 8H2 plus 8 times delta
Del two.
H2, it will give us 16H. And multiply this equation with again 8. So 8H2S plus 8 times delta H3 will give you 16H plus 8S. Now just make it A, B, C. So just do A plus
Plus B
B
minus C.
minus C. Then it will be S8 plus delta H1 plus 8H2 plus 8 delta H2 uh, 2 sorry minus, so minus means it will be 16H plus 8S, I think. Yes, it is 8S plus 16H plus 8H2S plus 8H3 delta H3, correct?
Yes.
So this will cancel out. So totally it is S8 plus 8H2, and it is H delta H1 plus 8 delta H2 minus 8 delta H3 to 8 H2S. Okay, and this should be the enthalpy. How the enthalpy
Yes.
is defined? If you consider this is the reactant side, this is the product side,
Product
then
side. This is delta H.
this is the delta H of the enthalpy change of the reaction, right?
Yes.
So here how you can define it? So this is in positive, correct? Positive means this
Yes.
amount of energy you have to give so that the reaction will occur. Okay. Now what will be our delta H of reaction? So you can write it as delta H1. The total bond energy, so you can think like that, delta of the reactants
Minus 8
minus
del H3.
delta H. So this is our HR. Okay. So if HR is if negative, that means that's a exothermic reaction, correct? You know.
Yes.
And if HR is positive, that means a endothermic reaction.
Endothermic.
So now you don't know whether it is an exothermic or endothermic. I should not draw it like this. We have to calculate it first. Okay. So let's say, so that means it means delta H1 is given 264 plus 8 into delta H2, that is uh, 436 minus 8 into 338. All are in kilojoule, not per mole. Okay, because you have multiplied with 1, 8, and 8. So this is not per mole right now.
This is for 1 mole.
No, for 1 mole, it was for 1 mole. Now you have multiplied with the 8. So this is for the reaction. So only kilojoule will be there, not kilojoule per mole. So it will be clearly positive. So this answer came to 1048 kilojoules. So it's positive, correct? So
Yes.
that means these are the reactants, and if you give the del HR amount of energy, then it will be converted to the product. So the should be like this. So this is the del HR. So that means del HR is positive. Okay. So directly you can do it, but I just wanted to construct the formula. Then you can. I think it's clear, right?
Yes.
Yes. Now this reaction, this is also very straightforward reaction. Question. So we should do it. Wait, 10 moles of a gas is allowed to expand from a state A at 10 atm and 300 Kelvin to a state B at 100 atm and 600 Kelvin if the value is known for CP. CP is given, that is 6.955 calorie per degree centigrade. Okay, just you have to calculate the entropy change of this process, right? What is the answer?
2.456 calorie.
Per Kelvin, right?
Yes.
Or per degree centigrade. That is the yes. So how do we do it? So 10 mole of a gas, it's expanding from state A to state B, and both state are defined. Cp is also given, so we have to calculate the del S. So there are few formula. Del S equal to
NCP ln T2 by T1
NCPM ln T2 by
T2 by
T1.
T1 minus NR ln P2 by P1.
Yes, exactly. P2 by P1. Okay.
Yes.
So N is 10. Yes, and CPM is given 6.955 ln T2 by T1. T2 by T1 is directly 2 NR, and it is 10 R. R will be
1.987.
calorie and ln 10. Correct? So it is okay. 1 minute. I think this is not for per mole. Otherwise, it will be mole inverse. It is not per mole. Okay. It is total. Total CP is given here
For 10 mole.
for 10 mole. Otherwise, there should be a mole inverse. If it is molar heat capacity, then obviously there should be per mole, but it is not. So it will be ln 2 to 26. So it gives us 4.848 minus. This is also here it will be obviously 10 will be there. right? Because it is 10 mole. Mm, or it is per mole. That is not explicitly mentioned. Do you have considered that 10?
Which 10?
The here in.
Yes.
Okay, then it is not mentioned. So please correct it then. It is then when it is per mole also. Now it's correct. So 10 you can take out, and it is now 1.1987 into 10. So it is
I have to see the unit of the CP.
what?
In this type of problem, I should see the unit of the CP for this
Yes.
mole.
No, it's generally it's written whether it's molar entropy or molar heat capacity. This is or mentioned actually, but here they have not mentioned. So that's why I we check the unit and unit there is no card mole. So if there is no card mole, that means it's a total heat capacity in general. But that should not be provided. Correct.
Yes.
Always it should be molar. That because uh, you know heat capacity is not a intensive property.
Yes.
Correct. But molar heat capacity is. So molar heat capacity is intensive property. So that's why molar heat capacity is provided. Okay.
Okay.
Okay. So now it will be then. So it is given into 0.2456 calorie per Kelvin inverse or centigrade inverse, whatever you want to write. So it is 2.456 calorie per Kelvin. Okay. So it's an easy question. Next question number 5. Okay, this is a quite unusual question. 2 moles of gas at 1 bar are compressed at constant temperature Okay. So 2 moles of a gas at 1 bar and 298 Kelvin are compressed at constant temperature by use of a constant pressure of 5 bar. So how much work is done on the gas? This is the first part of the question. And the
Okay.
second part is it fall in the Earth's gravitational field. That's the question,
Okay.
right?
Work done is 19.82 kilojoule.
9, 19.82.
Yes.
Yes. And the second,
Please wait. 2.02 meter.
minus, right?
Yes.
So how you have done this? Dictate me and I'll. First one is easy, I think, but still.
Yes.
So what will be the work done? You know work done?
Minus P external into V2 minus V1.
Minus PdV because we know D cross W equals to minus PdV and you have to just integrate it, correct? So it will
Yes.
be work done and because it's a irreversible process, correct? That's why it will be V2 minus V1.
Yes.
So P2 is 5 bar and V2 minus V1 that is important. V2 is given. So we can how we can V2 minus V1 how we can write it? V2 is NR
NRT by P2.
temperature is same, right? Temperature is same.
Yes.
So it is nRT by
P2 minus nRT by P1.
P1, correct. So it will cancel P2. So it is directly nRT. If you take common, then it will be 1 minus P2 by
P2 by P1.
12. So it will be minus nRT minus N is T2 moles, R is 8.314, T is 298, and it is 1 minus P2 by P1. P2 is 5, P1 is 1. So it is just 1 minus 5, so it is this.
Minus 4.
So you have to just multiply this. So it is 8.314 is 98. So it is 19.82 kilojoules. And now the second part. What is the
Work
question?
equals to force into displacement.
Hmm. So if the compression is driven by 1000 kg mass, hmm, how far it fall in the Earth gravitational field? So that's we are saying that this amount of work done, let's say given by 1000 kilogram mass, then what will be the displacement of the piston, right? That we have
Yes.
asked literally. Okay, so this work done is
Force into displacement.
force into displacement. So force is
Mass times acceleration.
mg,
Yes.
correct? And s is here actually h. This you know because this is the change of height, piston height.
Yes.
Okay, so or del h, whatever you want to write. So then it is mg del h. So m is 1000 kg,
1000 kg.
g is 9.8.
8 meter per second square.
Meter per second square, correct. So then we have to convert this at meter, so 10 to the power 3. And what is the del h that they have asked? So del h will be now, because it will decrease, so that means minus sign will be there. So that's why the minus sign is appearing. That you have to consider because it is decreasing, height is decreasing, or delta h is negative eventually. That's the reason. Okay, so delta h is minus 19.82 kilojoule divided by 10 to the power 5, no, 336 into 9.8. Okay, it is eventually
Why this is
I get
multiplied by 10
eventually
to the power 3?
it is eventually this. So it is 2 point minus 2.024.
Yes.
This you have done right?
Yes.
Okay. So it is question number 6. The molar heat capacity at constant volume of gas given by P V bar alpha beta T. gamma T square, where alpha, beta, gamma, these are given. Alpha is whole inverse. So what is the change? So the question is, what is the change in molar internal energy when oxygen is heated from 298 Kelvin to 500 Kelvin? Okay, right. Everything is given there.
Okay.
What is the definition of CV?
Del U del T at constant V.
Or
Del
before
Q
that, you
del
could
T
write
at
this.
constant V.
Okay,
Yes.
but that is obviously you can write considering this.
For this, it's del U.
Yes,
For this case, it is del U because it is constant volume.
no, actually not. So if you remember, how you can write it, that for the ideal gas you can write it,
Yes.
correct? Otherwise, because du d cross w, and d cross w for only if there is mechanical work, then it is pdv, and if it is constant volume, then it will be d cross q. Okay, that's the case.
Yes.
you can write it as del U del T P. Now, if this is correct, we have to calculate the molar, and if it is molar, then it is also molar. Nothing is there. So du should be Cp dt. Okay, and that in temperature is changing from 298 to 500. 298 to 500, and then it will be delta U that we have to calculate. So it will be 298 500, and you have to put it alpha beta t gamma t square dt. Okay, so it is alpha times t del t, alpha times del t plus beta t square by 2. Correct? It is from 298 to 500 plus 2 gamma t cube by 3, and it is 298 to
3769.36.
no, I don't know. Answer is not matching. Maybe you are correct. So alpha is 17.23, and the delta t is 500.
500 minus 298.
So that is 202 plus beta. Beta is
13.61 and 10 to the power minus 3.
3, and it will be by 2.
202 whole square.
It will be 500 square minus 298 square. Correct?
Yes.
And the last term, that is 2 by 3 into gamma. Gamma is 42.55 into 10 to the power minus 7, and it is cube, 500 cube minus 298 cube. Now calculate it. Seven 0.23 into 202 plus 13.61 into 10 to the power minus 3 into so what is your answer?
5794.
No, it's not matching.
5794.5.
1 minute. Let me do it part by part. 13 point. Do it part by part, then we can easily cross check. The first term is
3480.
3480.46, right?
Yes.
Second part, 13.61 into 10 to the power minus 3 divided by 2.
1097.96.
Yes. The last part.
1397.574.
Do you consider 10 to the power minus 3?
Yes.
1 minute. 5. Yes, what are you getting?
5974.
Getting 279 something into 10 to the power minus 7 into 500 cube minus 298 cube, answer divided by 3. Yes, this is I'm getting. Check it. Check the last part only.
Okay, I'm getting the same.
Okay. So it is 485690 joule per mole because this is molar. So this is the answer. Yes.
But why is multiplied by 2? The cube by 3, so it's divided by 3 only.
Okay, that is a function. Okay, you did not multiply, right?
Yes.
The answer? Four, right?
4716.
This part. 42.55 divided by 3 to the power minus 7. Is 139.
Yes.
717 joule per mole inverse.
I am getting this.
Okay.
Four seven one 6.7.
No, 17.14 I get. Okay, that's maybe or due to some we are adding now, so there may be some fraction. That's okay. This kind of question you can do. Heat of formation. Okay, do you want to solve this heat of formation kind of question? Okay, we'll solve before that. Solve it. Then we will solve. Evaluate. Okay, straightforward. Just solve it. Bar means per molar.
What is this BTP?
B is a constant. B is a not constant. B is a variable which is a function of temperature. P is pressure.
And P is a constant.
P is pressure.
Okay. Internal energy is independent of pressure.
Which one? B.
Internal energy.
Internal energy is independent of pressure. Why you have
Yes,
to consider that? That is not needed.
I am getting BT.
What is the answer? BT.
BT.
Okay, let us check. So what is DH? DU
DU plus PdV plus VdP.
and DU is
DQ minus PdV.
yes, and DQ then TDS will be there, but that is not important here. Okay, okay. Here you have to use the thermodynamics equation of state. What was the thermodynamic equation of state? There were
Dg equal to VdP minus SdT.
one was del U del VT, that was T times del V, no, press del P, del T V
Minus P.
minus P. This was internal pressure. And another one was del H del PT, that was minus V times del P
Del P del
del
T
T P
minus V.
minus P or plus. No, it is temperature, obviously temperature plus P. See, should be. Yes, I think. Then and then it will be obviously volume. Huh, it's correct. This is the equation of state. Okay. So here just we have to follow this. Correct. Del V del dp we have to calculate. This equation is given to us now for molar. It will be all molar. Okay.
Okay.
So now we have V bar equals to RT by P plus PP by P. PP cancel out, so it will be just P. So del V bar del TP will be RT by R by P. So it will be R by P plus D prime or we can write it explicitly as del B del T. Okay, is it clear?
Yes.
Okay, but it is, you can write it as dB, right? Because B is only function of temperature, so there is no need of partial derivative. It's R by P plus dB dt. And the V bar is already you have calculated, that is RT by
RT
P
by P.
plus B. So it is clearly V minus T times dB dt. So this
I
is
did not consider that. Sorry.
which one you did not consider?
T dB dt.
Okay, that you have to also consider. No? This kind of question you can have in the exam. Okay, because this is a very difficult question, but quite upbeat. Okay,
Yes, I think B is independent of temperature.
no, then what is the meaning of it? It's all clearly written as B is a function of temperature.
Yes.
That is clearly written. Okay,
This question asked in net.
can be, because day by day these questions are become more creative.
Yes.
They actually don't want to follow the direct copy paste question. Obviously, there will be some, but they want to have some kind of variation. Okay, that's why they are forming new kinds of question, new types of question basically that are not very difficult, but that is quite not traditional. Okay, so just you have to think, you have to give some input of your knowledge and imagination, then you can solve it. Yet you don't need to solve very long, or you don't need to uh, invoke very special knowledge. That's not needed. That's the knowledge is required. That is, you know, that is the common knowledge, but you have to just implement that knowledge. So this kind of question they are making quite tricky. So now the calculate the enthalpy of fusion delta H F of ice at minus 10 degree centigrade from the following data. Which data? The delta H F at 0 degree Cp of ice is what?
LCPDT
Cp but but there is
del
no
H equal to
Yes, uh, but there was 2 minus del H1, correct?
Yes.
Kirchhoff formula, Kirchhoff equation. Okay, that we have to invoke here. So now we have to calculate enthalpy of fusion del HF minus 10 degree. Okay, so del H at minus 10 degree, you have to calculate. It is del H, 0 degree is given. So it is clearly T1 is 290, sorry, 273, 263. And delta Cp. What is the delta Cp? Delta Cp is the Cp at
Change in heat capacity.
minus 10 minus Cp at 0.
0.
This dt. So this is given at minus 10 means it's ice clearly. So it is minus 30, sorry, 37, right?
Yes.
Oh no, but it is the important thing is it is water minus ice or ice minus water that you have to consider. Delta Cp, that is Cp water minus ice.
Fusion means ice to water.
No, but you have to remind one is fusion means ice to water, correct? Yes. So and this is the delta H of fusion, correct, correct. So delta Cp is for ice to water. So, because it is fusion, right? So it is then it will be water and it will be ice, I think.
Yes. Final minus initial.
Hmm. And it will be delta T, which is minus 10. Clear?
Yes.
So it is what will be the unit? Joule per mole. This value was given as 6.02 kilojoule. That means 6020 joule minus 6.0. This is the answer.
Yes.
Question number 9. Okay. This is heat of vaporization. But this kind of question we have done. So just let me find out some different. Yes. Okay, this is a long question. A gas, ideal gas Okay, so gas, not ideal gas, is obeying the equation of state, that is, let me write it here, which undergoes a change from the initial state T1 V1 to a final state to derive an expression for the entropy change of this gas. The variation of heat capacity at constant volume is given by Cv equals to A plus Bt plus Ct square.
Okay.
It's the update. The gas undergoes from the initial state T1 V1 to T2 V2 and derive an expression for the entropy change of this gas. So how you can approach it?
From the formula of entropy.
Yes. But if you remember that formula, what you have write, that del S equals to something something, that is for the ideal gas. Correct? So you have to
Yes,
just construct that formula for the
I am telling dq reversible by t.
what?
Del S equal to dq reversible by t. Then
Okay.
from that,
D cross Q by T, right?
yes,
And what is D cross Q?
du
Plus
minus pdv
plus PdV.
plus pdv.
Because you know du equals to D cross Q minus PdV. Okay. So this you know. And du is
CVDT.
that is also for ideal gas.
Yes, but the expression is only different. CV is given.
No. What is du?
Then I have done wrong.
This is du, na?
Yes,
And this is called CV, CVDT, but this part is zero for ideal gas. But here it is not
pi
zero.
TdV.
Hmm. Pi T, pi T, exactly, pi T.
Pi T is non-zero.
Yes, because it's not an ideal gas right now. So you have to consider that also. So let write it as pi T. And this is CV, CV, not bar, CVDT. Okay. So that you have to invoke here. So ds will be CV dt by T or CV by T dt plus P by T dV plus pi T by T dV. Okay. This
Yes,
we are getting. Now pi T, for pi T we know pi T was already you have right.
minus p.
Let me check. Yes, correct. This is in general. So, so if you put it, then ds will be del p v times dv minus p by t times dv, and it will cancel. Okay. And what is dp dt? It will be, because it is given, what is given? P equals to RT by V minus V, that is given, right? P del T V will be R by V minus V. Is it correct?
Yes.
So this is clear. Now just we have to put the CV. CV is already given us. CV is A plus BT plus CT square by CT. So the final expression will be A by T dt, B dt, CT dt plus R by V minus V dV. Now to have explicit value total, yeah, we have to integrate. So del S will be, what will be, A is constant. So A 1 by T. So 1 by T will be ln. So ln T2 by T1. It is D T2 minus T1 plus C will be T square by 2. So C by 2 T2 square minus T1 square, and this part will be R ln T2 minus B by B1 minus B. Okay, this will be the form.
Okay.
What is problem? We are reminding those formula which are derived from the ideal gas that we forgot.
Yes.
So whenever you have departed from ideal gas in the question that is mentioned that you have considered another kind of gas which has a special equation or particular correction in the ideal gas equation, then you have to uh, reconstruct the formulas. And you have to start from the scratch. What is the general formula? That is the first law of thermodynamics. Then you have to go step by step. Keep in mind that you are doing it for a non-ideal gas. Then you can derive it. Otherwise, if you just go by the formula you have remind, then you will be in trouble because maximum of those formula is derived for the ideal gas, which you can't use for a non-ideal gas asked in the question. Okay, so that you have to always
Yes.
keep in mind. Okay, now one question from the Carnot engine. Question 9, question number 10. I think this is very, very easy. I'll not do it. Very easy question. Sorry. Okay, let me do a different question. Okay, 1 mole of toluene is vaporized at its boiling point, which is 111 degree centigrade. The heat of vaporization at this temperature is 363.3 joule per gram. Now they ask calculate the maximum work done against 1 ATM. Okay, this you have to calculate. Q you have to calculate. Del H you have to calculate. Del E or del U, whatever you want to say. Calculate del G you have to calculate. Del S you have to calculate. All for 1 mole of toluene. That you have to consider. And obviously you have to consider paper is ideal gas. Paper behaves like the ideal gas. Okay, so let me do it. We have completed and then we after this question we discuss the third law of thermodynamics.
Delta H is the heat of vaporization.
No, 1 mole of toluene is vaporized at its boiling point, 111 degree centigrade. The heat of vaporization at this temperature is this. So let me consider
Enthalpy is same as the heat of vaporization.
why.
I learned in the college. For phase change, delta H is same as the heat of vaporization.
Okay. So now what is going on? Toluene, right?
Yes.
That is in liquid and goes to
Toluene vapor.
vapor at 111 degree centigrade. This is going on, right? So first we have to calculate the maximum work done against 1 atm pressure. So what will be the work done? You know. What will be the work done?
PdV
PdV.
plus VdP.
No, actually no.
In a tail and V2 by V1.
You have to remind that. You have to remind one thing. You have to remind this is liquid, this is vapor. So yes, PdV is correct, but you have to simplify the PdV. That you have to simplify. So it will be P Vg minus V liquid. Then write it.
Yes, yes. So it can be neglected.
So it is PVG and PV equals to RT because they have said it is a ideal gas. And it's 1 mole, so it's RT. So R is 8.314 and P is 3834 Kelvin.
111 degree Celsius.
But Kelvin is 383.
Yes.
So it is 3.184262 joule. It is joule per Kelvin, right? So it is just joule. Mole is not important. Okay, you can give mole because it is for 1 mole only. So it is 1%. Okay, do you get the same?
Yes.
Okay. Now what they have asked next? They have asked that
I am getting 3.192.
you are getting correct. Okay, now they have asked the Q. So this is a constant pressure process, correct?
Yes.
No, for constant pressure process, QP is actually the del H.
Yes.
Okay. So you can del H for vaporization that you have already known. That is given. So what is that? That will be now 33.3 joule per gram. But now you have to multiply with the gram. That is important. How many gram is present? Because this is 1 mole. This heat of vaporization is provided here. You can't write that answer directly. For the daily change also, the daily and QP is the same here. You are correct. But you have to keep in mind it is per gram is given in the question, but they
Yes.
asked per mole. So what is the weight for 1 mole of toluene? Toluene is
PHCH3.
what is the molar weight? 6 carbon 78. What I'm saying 6 carbon 7 carbon 7 carbon, so 84, correct. And 3 hydrogen, that means 87, and here
86.
5 hydrogen, no, 92. Check it, 92. 7 carbon.
Benzene is 72. So minus 1 is 71 plus 12 plus 3.
Benzene is 72, 78.
Sorry, it's 78.
It is 92.
94. Sorry,
No,
92.
92. And unit would be gram per mole.
Yes.
And it is then 3.423 joule per kilojoule per mole, sorry. Okay. So this is okay. Given Next is del u. Del u, what will be the del u? Now you have calculated main thing, then you can easily calculate.
minus P delta V.
Okay,
It is constant pressure process.
so del H is
33.423 kilojoule.
and PdV, PdV that we have already calculated, work done, right?
363.3.192.
Yes. So it is eventually mm, 3.19. So what is the answer?
30.333.
333 or 233?
303.
Ah, but you have to take the one terms. You not written them.
Okay.
So more. And next, calculate del G and del S. Del G, what will be the del G?
Del H minus T delta S.
That means you need S. And del S will be
dq by T.
and dq is del H vaporization
Del H by T.
by T. So it was
T is boiling point.
temperature is 300.
111 degree Celsius.
So what will be the answer? Do it.
0.0870.
Now, if we go to June, then it will be the answer. And last, what will be the del G? So it is 0. Okay. Because T delta is del H vaporization and del H vaporization and del H vaporization will be 0.
Yes, it is 0.
That's it. Or you can do it other way around. D is equal to VdP
VDP
minus
minus SDT.
SdT. This is anyway 0.
Yes.
Constant pressure process. And that is SdT, constant temperature process. So that is also
So
0.
it's 0.
It's 0. Okay. Okay, so it was question number 10. Okay, it's okay. Now we can discuss this. What is the third law of thermodynamics? Let me write it. This you have already known, but still. Mm, yes. So let me write it. Law of thermodynamics. What is the third law? Yes,
At
yes.
0 Kelvin, pure substance has entropy 0.
The
Pure
entropy.
crystalline substance.
Yes, the entropy of a pure perfect,
Crystalline. Perfect crystalline.
yes, ordered crystal or crystalline solid has is 0 at 0 Kelvin. This is our third law of thermodynamics. So here two constraints are there. you can say. First one is the pure, and second one is the perfectly ordered. Pure and perfect crystalline solid you have to consider. Then only you can say it is zero. Otherwise, it is nil. Okay.
Yes.
So you can write it in mathematical form. So del S will be zero. No change will be there, but it's correct. But it is for purely and perfectly ordered crystalline solid. Okay. So what we can write, then obviously ds, what will be the ds for any temperature from 0 to, so you can write it. If you changing the temperature from 0 Kelvin to T Kelvin, then ds will be this, correct?
Yes.
And this you know, this formula ds equals to cv T2 by
T2
V1,
by T1.
and there will be no ln V2 by V1 because that is for
Yes.
this is solid, so V2 and V1 will be the same, so that part will not be there. So this is the formula, and after integrating, we obtain that. If you remember,
Yes.
this is delta S, not the ds. So this is delta S. So let me clear. Delta S is this, and you know the ds is Cv dt by T. So what you can write, delta S, you can write sum over integration over ds S0. So clearly St equals to S0 plus integration of delta S, and it is Cv dt by T. And this change should be 0 to T. Is it clear?
Yes.
Okay. So this is the formula you have to, you should not remind, you can do it.
S0 is 0.
S0 is 0 if it is a pure and perfectly crystalline solid.
Yes.
Okay. And related to this, we can solve a question also. Easy question, I think so. So that the entropy of any substance at very low temperature, how low it is, this kind of low, where E by relation for heat capacities of crystals is valid. Is, you have to show it, is one third of the molar heat capacity. So entropy of any substance at very low temperature, this temperature where Debye heat capacity is allowed. So what is the Debye heat capacity? That is proportional to that heat capacity proportional to T to the power cube, if you remember, right?
Yes.
So it is Cp equals to, you can write A T to the power cube, where A is a constant, any constant. Why Cp? Because we are now considering the solid.
Yes.
So that's why it is Cp. It's a t to the power q. If it is Cv, then also it's not important. Then a or b, a will be changed to another constant. That's the case. Both Cp and Cv both will be a function of t to the power 3. So now, if this is the case, uh, 1 minute. Okay. Hmm. One thing you may ask that this ds, you can write it as Cp dt by tt, dt by t as well, right?
Yes.
Okay, but in case of Cp, there was pressure. So which one you should write, Cp or Cv? That is depend whether it is a constant pressure or constant volume process. Okay.
For solid, it's constant volume.
If it is constant volume process, then obviously you CVDT you can write. But if it is a constant pressure process, then CVDT it's better to write. Okay. So that you
Yes.
keep in mind. Although it is a solid, in case of solid, the volume is more or less same, but pressure cannot be. So CPDT by T and there is, but NR will not be there. So it's better to okay, I understand. Okay, it's better to have the difference. Okay, this is for constant volume, this is for constant pressure. Okay.
Okay.
So for constant pressure, you will have the similar expression. Let me write it. For constant pressure, you will have the similar expression. Just instead of volume, it will be just constant pressure. So you see, for constant pressure, the entropy and constant volume that will not be the same. Clear?
Yes.
Okay, great. So now it is Cp equal to this. Then what will be our? Just we have to write it that St we have already derived. Correct? Cp is given a t cube by t, so it will be t square, a t square by dt, a t square dt, sorry, and 0 to t. Okay. And now if it is a perfectly crystalline solid, then we can write, if it is a perfectly crystalline solid, obviously, then can write AT will be, ST will be this. So it is the third order. So what is Cp by 3? Is it clear
Yes.
that they have asked to show? Okay. Now, yes, it's clear.
If it's CV, then it also be same.
Yes, you can do it in terms of Cp also. Then just instead of Cp, you have to carry Cp, and then again you have to, you will have the same answer. Okay.
Okay.
Residual entropy. This part already you know, but still.
Yes.
Okay. So this, let me first define. Entropy is the difference between entropy between a non-equilibrium state and crystal state of a substance. That's interesting. There are certain solid, okay, that's correct. Certain solids are there like H2, D2, CO, NO. Okay, that does not have a perfect crystalline structure at 0 Kelvin. So they
Yes,
have certain amount of entropy at that absolute zero, and that is the residual entropy. That's the case, which I've written there is formal language. So that's basically, you know, that S0 is zero, but that is, or you can say limit t tends to zero, ST is zero, but that is for pure and crystalline solid. If it is
perfectly
for pure,
crystalline solid.
pure, it's pure, but what it's not perfectly crystalline solid, then due to their orientation, there will be some entropy. That is called the residual entropy. And how you can calculate those residual entropy? Residual entropy
KB ln omega.
yes, it's S to be K and then omega, where omega are the
Microstates.
microstates formed due to orientation, right? Different orientation.
Yes,
A is the Boltzmann constant. So should we solve some example? Do you remember? For carbon monoxide,
yes,
it is easy. For carbon monoxide, there are two orientation, right? Carbon
yes.
monoxide may be this way or this way. These two orientations are there. Sorry, triple bond. If there are two orientation, then obviously the entropy will be residual. Residual entropy will be KBln 2.
5.76.
But okay, you don't need to solve it. It's KBln 2. And
I remember it.
okay. And if it is for molar, then you have to multiply it with the Na. Correct?
Na.
Then it will be RLn2. These are some examples. Okay. So these two things I thought to discuss. Yes, it's okay. Okay, so can stop here, but still we have some time. Let us discuss our more question. Then we will stop it. In next class, we will discuss that Gibbs Helmholtz equation and the Joule function as we have planned.
Okay.
Like it will solve. So okay, do it. In this question, you can DLS mix. No, this you can. It's completely different. Okay, this question is last question. The enthalpy, probably it was again disconnected. Okay, the enthalpy of the reaction, which reaction? Al2 Cl6 plus Na, that goes to 2 aluminum plus 6 NaCl. This is given, enthalpy change is given, that is minus 250. So it is a exothermic reaction, right?
Yes.
Kilocalorie. They have asked the heat of formation of solid NaCl is minus 98.2 kilocalorie again. This is given. They want to know, calculate the heat of formation of solid Al2Cl6. So this formula is known. Already we have derived that del H of reaction is actually the uh, heat of
Del H
formation.
reactant minus del H product.
Yes, that means the heat of formation, whatever you want to write. But before that, you have to just write down the reaction. The reaction, right?
Yes.
Now, so heat delta H of R, that will be the heat of formation of reactants minus heat of formation of product. Okay. So what will be for reactants? Al2Cl6, that you want to have calculated, let's say X. This for Na it will be 0. It's a pure substance.
Pure substance.
Aluminium is 0 and it is given, that is
6
minus.
into NaCl.
Yes. So it is clearly X minus uh, okay. No, here is a catch. So it will be products minus reactants. Why?
Heat of formation.
It's heat of formation. That means while formation, the heat is
Released.
released. But previously it was bond energy. That
Yes.
means the energy provided due to formation of uh, due to formation of bond, the heat is released. They are due to formation of bond. But uh, here also due to formation of bonds. No, 1 minute. Due formation. Yes. Correct. It's correct. There it was. Let me clear it. It is Al2Cl6, right? Here it is forming from aluminum and chlorine. Okay. So you have to consider it is from aluminum and from chlorine, Al2Cl6. Kind of this. Okay. If you
Yes.
want. But in case of bond energy, you have to reverse one. You have to consider. That means if you burn it or if you just break down, then how much energy is released? Because it's bond energy, correct? That means the energy stored in the bond. So it's a reverse thing. That's why it is product minus reactant. Okay. So
Yes.
product is 6 into 0.2 and it is minus x and it is 256.8. So x will be all was in kilocalorie. Okay.
Okay.
Okay. So let me sharing that. Yes. Okay, so again we'll meet in the day after tomorrow. It's just one day. Okay, and we'll discuss that part. Okay,
Tomorrow.
day after tomorrow, 15th,
Okay.
from 3 p.m. Although they have not confirmed yet, I just feel that Google form they have sent for the extra session that I have filled. I'll mail them. Okay, then probably it will be on 15th from 3 p.m. to 5 p.m. Then we can that will be our last class, extra class, and we'll discuss that these two part. And if you have any other doubts, you can ask. And if time permits, then in rest of time we'll solve few other questions.
What will be the time?
3 p.m. to 5 p.m. 2 hours.
3 p.m.
Hmm. Do you have any problem?
No.
Okay, because that's the holiday.
Yes.
So I think so. Okay, so thank you for joining. Again, we'll meet on Tuesday.
Okay.
Okay, thank you.